All right, so now we're going to talk about conditional probability. So conditional probability. Okay, so if A and B are events with probability of B not equal to 0, then the conditional probability of A given B is this formula right here. Probability of A given B is equal to the probability of A intersection B over the probability of B. Okay, so let's do an example of this. So example, if you roll a fair dice and observe the numbers that face up, find the probability that the sum of the numbers is 8, given that the first number is 3. All right, so the first thing we got to do is we got to set up our sets, our events. So let A be the sum of the numbers is 8. And let B be the first number is 3. See how those are the two events in the example? Okay, so we want probability of A given B, right? Which is probability of A intersection B over the probability of B. So first we got to find the probability of A intersection B. So what is A intersection B? What event is that? So that's the sum of the numbers is 8 and the first number is 3. Well, that's only one outcome, right? That's 3 and 5. Because this first number is 3 and the sum is 8, right? So remember, the probability of A intersection B is equal to the number of elements in A intersection B, which in this case is 1, over the number of elements in our sample space. Now remember, so this is going to be 1. In our sample space, this is going to be, remember there's 2 dice, right? So it's going to be 6 times 6, right? Which is 1 over 36, because there's 2 dice. So you do the number of sides on one die times the number of die on the other side, on the other die. All right, so now we need to get the probability of B, right? So what's B? The first number is 3. So B is this event. The first number is 3, so 3, 1, 3, 2, 3, 3, 3, 4, 3, 5, and 3, 6. Right? So the probability of B is equal to the number of elements in B over the number of elements in the sample space, which is 6 over 36, right? Okay, so now the probability of A given B is equal to the probability of A intersection B over the probability of B, which is equal to 1 over 36 over 6 over 36. And remember, when we divide fractions, we leave the top alone. So 1 over 36 times, and then we flip the bottom, 36 over 6. The 36's cancel, and you're left with 1 over 6. Okay, so now let's move on to independent events. Okay, so independent. Okay, so the events A and B are independent if the probability of A intersection B is equal to the probability of A times the probability of B. Okay, so a quick example. Roll 2 distinguished distinguishable dice, 1 red, 1 green, and observe the numbers that face up. So let's let A be the event. The red die is even, and B be the event. The dice are both even or both odd. Okay, so let's figure out what A intersection B would be then. A intersection B would be both dice are even, right? So now, what would A be? A would be equal to, let's see, the red die is even. So 2, 1, 2, 2, 2, 6, right? And then 4, 1, 4, 6. And then 6, 1, 6, 6, right? So as you can see, the red die is even. That's half of them all, right? So the probability of A is going to be there's going to be what, 18? So the number of A over the number in sample space. So the number in A is going to be 18 over, and the number of S, remember that's 36 because there's 2 dice, right? So that would be the probability of A. Probability of B. Oh, we got to figure out what B is first. So B is, the dice are both even or both odd. So B, both even or both odd. So 1, 1, 1, 3, 1, 5, 3, 5, or 3, 1. As you can see, this is also going to be half as well. 6, 6. This is going to be half of them as well. So the probability of B is going to be the number in B over the number in S, which is going to be, number in B is going to be 18, and the number in the sample space is 36. So probability of A is going to be 1/2, 1/2. And the important part is, what is the probability of A intersection B? That's going to be the number in A intersection B over the number in S. The number in A intersection B is going to be 9 over 36, equal to 1/4. Okay. The number in A intersection B, both dice are even. So we can see that here really quick. A intersection B, both dice are even. So that's going to be half of B, right? Since there's 18 for yeah, the red die is even, so it's going to be half of A. But we can do this here. So it's going to be so both the red die, both dice are even. So 2, 2, 2, 4, 2, 6, 4, 2, 4, 4, 4, 6, 6, 2, 6, 4, and 6, 6. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9. So as you can see, the number in A intersection B would be 9. So let's determine if this, if these two events, the red die is even and the dice are both even or both odd, if both of those are independent or not. So all we got to do is, what is the probability of A intersection B? So that's 1/4 equals the probability of A intersection B, which is equal to, okay, so that's that fact, right? And we have to set it equal to probability of A times probability of B. But remember, that was 1/2 times 1/2, which is equal to 1/4. So we have that the probability of A intersection B is equal to the probability of A times the probability of B. Thus, A and B are independent. All right, that's it.